Integer exponents and the quotient rule. Notice this pattern. 3 to the 4th is 81, 3 cubed is 27, 3 squared is 9, 3 to the 1st is 3, 3 to the 0 is 1. We're subtracting 1 from the exponent every time on the left. If we subtract one more time, we'll have 3 to the negative 1. On the right side, we're dividing by 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Now 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. 1/9 divided by 1/3 is 1/27, and so on. So you can see that a negative exponent does not make a number negative. It makes it much smaller. Our property here on negative integer exponent says let a be a non-zero real number and n be a positive integer. Then a to the negative n is equal to 1 over a to the n. That is, a to the negative n is the reciprocal of a to the n. Look at this example, x to the 5th over x squared. X to the 5th means x multiplying itself 5 times, and x squared is x multiplying itself twice. Now when I go to simplify this, I cancel my x's, as many as I can. Now I've run out of x's on the bottom to cancel, so I have just x cubed left. Now we wouldn't want to do this method if we had something like x to the 19th over x to the 12th. So what's the shortcut to get from here to here? Of course, we subtract the exponents. So x to the 19 over x to the 12th is x to the 19 minus 12, which is x to the 7th. This gives us the quotient rule for any non-zero number a and integers m and n. A to the m over a to the n is a to the m minus n. We already know that a to the negative n equals 1 over a to the n. Now look at these other negative exponent properties involving quotients. 1 over x to the negative 2. How could I express this as a positive exponent? Well, one way would be to multiply by x squared over x squared. This gives us an x squared on the top, and an x to the negative 2 plus 2 is 0 on the bottom, which we know is 1, so we end up with just x squared. So if we have a negative exponent, it needs to go to the other side of the fraction bar. The same with this one. M has a negative exponent, so it's going to send it to the other side of the fraction bar and become a positive exponent. B has a negative exponent, so it gets sent to the other side of the fraction bar and the exponent becomes positive. Here, let's do this one the long way. I would have t to the negative 4 over r to the negative 4, which from this example I know is going to be r to the positive 4 over t to the positive 4, which is the same as r over t to the positive 4. So how could I get from here to here? All we need to do is take the reciprocal of that fraction, and then the exponent becomes positive. This gives us our other rules for quotients and negative exponents. The following 3 rules hold for any non-zero real numbers a and b and positive integers m and n. Number 1, 1 over a to the negative n is equal to a to the n. Number 2, a to the negative n over b to the negative m is equal to b to the positive m over a to the positive n. And last, a over b to the negative n is equal to that number's reciprocal, b over a, to the positive n. Now knowing these rules, let's simplify these expressions. First, I have the negative exponent, 4 to the negative 1. This is the same as 1 over 4 to the positive 1, or 1/4. Here, 1/3 to the negative 2. Remember, we take the reciprocal of that number and then the exponent is positive. So we have 3 squared, which is 9. 5 to the negative 2 over 5 to the negative 4. I could go ahead and switch the positions of these exponents, or I could just simplify by subtracting my exponents. I have 5 to the negative 2 minus the exponent on the bottom. This gives me 5 to the negative 2 plus 4, which is 5 squared, giving me 25. Here, 2/7 to the negative 2. Again, I take the reciprocal of that number and then the exponent is positive. That gives me a 49 over 4. Simplify the expression. Write the answer using positive exponents. Here, x squared, y to the negative 3rd, x to the negative 5th, and y to the 6th. Let's go ahead and combine our x squared and x to the negative 5th. That gives us an x to the negative 3. Remember, when we're multiplying numbers of the same base, we add the exponents. With the y's, I have y to the negative 3rd and y to the 6th, which makes a y to the positive 3. I know I have a negative exponent, so it's going to be sent to the denominator in order to become a positive exponent. But my y cubed is already a positive exponent, so it can stay on top. Here, xy to the negative 3. We could do this a couple of ways. We could take the reciprocal, and then the exponent becomes positive. Then we have 1 over x cubed y cubed. Or we could go ahead and use the exponent right away and make it an x to the negative 3, y to the negative 3, which is the same as 1 over x to the positive 3, y to the positive 3. A to the negative 2 to the negative 4. Remember, when we're raising a power to a power, we simply multiply those exponents. So we're going to have a to the positive 8. Now we have no negative exponent, so we don't need to go any further. Here I have an rt cubed to the negative 2. Let's make this a r to the negative 2, t to the negative 6. This gives me 1 over r squared t to the 6th. Similarly, we could use our reciprocal rule, where when I have a negative exponent outside my parentheses, I simply take the reciprocal and then the exponent becomes positive, which gives me a 1 squared, an r squared, and a t cubed squared, which is t to the 6th. ab squared times a squared to the negative 3rd. First, let's square this. We get a squared b squared. Here, I'll have an a to the negative 6. Now, when I'm multiplying a squared and a to the negative 6, that gives me an a to the negative 4, because I simply add the exponents. Now my a has a negative 4 exponent, b has a positive exponent, so it stays on top, but my a to the negative 4 is going to go to the bottom so that the exponent can become positive. Here, x to the fourth over x squared is the same as x to the 4 minus 2. This gives me an x squared. Negative 4 xy to the fifth over 6x cubed y squared. First, we can cancel. We know that 2 goes into 4 twice and into 6 3 times, so we'll have a negative 2 over 3. I have an x and an x cubed. I know that I can cancel one of those x's with one of those, and I'll have just an x squared on the denominator. For my y, I have 2 on the bottom, 5 on the top. So 2 would cancel 2 of those, and I would have a y cubed left on the top. Here, I have an x to the negative 4 minus the exponent on the bottom. So x to the negative 4 plus 1 is x to the negative 3, which is 1 over x cubed. A over b to the negative 2 is b over a to the positive 2, which gives me b squared over a squared. U over 4v to the negative 1 is the same as 4v over u all to the positive 1, so we don't need to go any further on this. Here are your rules for integer exponents.